Hello, everyone. Welcome to my lecture about resumable persistent functions, or how to build a chatbot the fun way. So before I get started, let me introduce myself. I'm Alon Gal. I'm a software developer at K-Health. K-Health is a medical company that does all sorts of things to improve our users' health. And specifically relevant to this talk, we have chatbot that is a symptom checker. Basically, the user says they have some sort of symptoms that they're feeling. We ask them a bunch of automatic questions. And finally, we diagnose what medical conditions we think they might have. So my talk will all be about how to build this infrastructure and a library that we developed in order to make building this kind of stuff easier. So to make it as concrete as possible, we're going to start with an example. The example is a Guessbot. Basically, we're going to build a game together. Our game will consist of the computer generating a random number between 1 and 10, and then the user needs to guess what the number is. So as you can see in this gameplay demo, the first guess was 5, which is not correct, and then the next guess was 2, which is correct. And so we're simply going to write code that does this. And the first version is probably the kind of thing you might learn in a beginner's programming class, the local version. Local in the sense that you're running it on the same computer that is playing the game. So let's go over this one by line. We first print the prompt. Let's guess a number between 1 and 10. We then generate a random number, which is the correct number. And then we enter this infinite loop, this while true, which on every iteration, it takes input from the user. It compares the input against the correct number. If it is the correct number, it stops the loop, it breaks out. If it's not, it says that's not it and lets you guess again. Then once you escape the loop, if ever, then it says, awesome, the number is the number you guessed, and bye-bye. Now, hopefully this code isn't too tricky. It's not meant to be tricky. And this is kind of the most natural way to write this sort of thing. So let's talk about some of the properties of this local version. So first, it's very readable. You can go line by line. You understand where you are in the flow, and you can manipulate it easily and understand it. The second point is that it's testable. You can, by patching the input function, or you can kind of give a stream of guesses and easily test that the function does what it's supposed to do. And finally, it does not have any persistent state. This basically means that you have to be on the same machine that's running this in order to play the game. This cannot be kind of hosted on a remote server somewhere, which means that you cannot build a mobile app with a chatbot this way, even though you would like to. So this is the local version. Next up would be kind of the server version, which is what you would write in a real backend if you want your mobile app to reproduce the same experience. And we have a lot of code that is kind of similar to this in K. So let's go over what's going on here. So this is the endpoint code. We first fetch the state for this particular chat. We then have to start kind of understanding where we are in the flow. So the very first check is actually to test if we're done. If the state says that we're already done, then we don't need to return any messages and we stop right there. Then the next if, in case we're not done, is to test a Boolean that says, are we the first message? If we're currently looking at the first message, which means this is the first time the client ever spoke with us in this chat, then we need to kind of do some initialization. So we set the correct number, which is also inside the state, and then we unset the is first message Boolean. And of course, both of these need to be saved into the database in order for us to understand where we are on the next request. And then finally, we return the prompt, which is guess a number, and return control to the client. Finally, the last if says, assuming that we're not done yet, and it's not the first message, and we're assuming that this is a guess. So we're interpreting the user message as a guess, and we're comparing it with the correct number. And if it's not the correct number, then we say that's not it, and return that's not it, and then let the user try again. And finally, if we made it all the way across these three ifs, that means that we're not done yet and it is the correct number, and so the user was successful, we should set state.isDone to be true and return a success message saying, awesome, the number is blah, blah, whatever it is, bye-bye. And so I hope it's clear that it's kind of, I hope the motivation is clear for why this is harder to read than the local version. Basically, you cannot read this line by line to understand the game flow. We actually start from the very end because this is kind of the first case that we want to check to see that we should stop. So we actually, the first check is done. And then we kind of have to manipulate these state variables, which is done and is first message. We need to manipulate them manually in order to understand where we are in the flow and allow the user to go continue where they left off from their last request. Let's zoom in on this state that I mentioned before. So this is a data class that has three variables. The first is first message, which is required because the first message has special behavior. Instead of checking the number, we need to show the prompt. Then we have the is done Boolean, which is initialized to be false, which basically means the game is over and we shouldn't return anything. And we have the correct number, which also needs to be persisted. If it's not persisted, then we don't remember what number we guessed, and then the user we don't have anything to compare the user's guess to. So I'm sure many of you have seen code like this for any sort of application that is more than one request old. And it basically requires the programmer to understand very deeply the database state and manipulate it such that the code does what it's supposed to do. And so I just want to highlight that these two variables, the is first message and is done variables, did not exist in the local version. They're new artifacts that exist only to kind of navigate us to the correct place in the code. And this is new variables imply new logic that the developer needs to keep in their head. So let's go over this. This is hard to read. It's hard to test because you need to reproduce the state in an exact, you need to reproduce the state exactly for each possible flow. And it requires explicit state management. The function itself needs to know about is first message, is done, and manipulate them in each state of the execution. And so the premise of the library that I'm going to describe in this talk is, can the server code look more local? Basically go from the second version I showed you to the first version while keeping all the benefits of being on the server. And the answer is yes. And that's what we're going to look at now. So the idea of the Dialogs framework, which is the library that I'm showing, is to write normal looking code, normal meaning local looking code, just flowing line by line. And the framework makes sure that the requests magically resume execution where it was last stopped. So let's see the code to kind of see what I mean by this. And there it is. This is actual code. It's not pseudocode. You can find this on the GitHub link in the description. And this is the same server code, but in while using the Dialog framework. So before I go into all the magic symbols here, and there is some magic going on, let's just look at it line by line and kind of see the obvious resemblance to the local version. We start by sending the prompt. We then say generate a random number. Then we go into this while true loop. Instead of input, we run this thing called get client response to get the user input. We then compare it to the correct number. And then if it's not correct, we send it's not correct. And basically, the flow should be very familiar. Now, let's highlight some of the magic that's going on here. So the first thing is this decorator dialog that we need to put over the function. This decorator indicates that this isn't just a normal function, but this is a dialog that is meant to be run using the Dialog framework. The next kind of weird thing that we see here is that almost all the lines contain this command called run. And run is also part of the framework API. And run basically means whatever's inside the run, the argument that it gets, we want you to run, but only if you haven't reached that point yet. So every time I reach a run command, I either run it or not run it, or I don't run it, depending on where the execution got to so far. And finally, we see two primitives that we export from the framework, which is send message and get client response, which are basically the way to interact with the user. So send message means add an object to an array which the user will receive at the end. And get client response basically means we're halting execution there. We're letting the user respond to whatever happened or waiting for the next user request. And then we continue the execution from where we left off once we have this answer. So I'll let you just stare at this for like 5 more seconds and move on. All right. Let's see how this integrates with the actual endpoint. So this part about pulling the state is very similar to what we saw in the other server version. And here we basically have boilerplate. Whatever your backend logic is, you're going to have almost exactly the same code. In order to highlight kind of what we're seeing here, so first we have the most important thing, which is game. This is the function that I referred to, that we saw in the previous slide, which is the definition of the actual dialog that we want to run. Then we have run dialog, which is our API for running the top-level dialog, meaning the one that is actually written inside the API code, so not inside a dialog. And we have this thing called next step, which is what run dialog returns. And this is the way to access all the messages that we got. And we can also, of course, do some post-processing here to turn them into JSON or whatever we need for our backend framework. And so this is kind of the extra boilerplate that you need to put on your endpoint in order to utilize this, this framework. So let's do a quick comparison of kind of the nifty stuff or the good stuff that is motivating us to use the framework. So first we have this extra variables that we needed to know where we are. So in the local version, we don't need them. In the server version, we do. And in the framework, we, again, don't, which is a good thing. It's less stuff that the developer needs to worry about. Then we have the persistent state, which is not possible in the local version. Meaning persistent state means that everything is in the database and you can kind of access it remotely. Whereas the server and the framework version do persist the state, and readable flow, readable code, and then this is the main point of it all. And of course, there's a happy smiley on both local and framework, while the server is convoluted. You have to kind of warp your business logic to match this fact that you're in a client-server ping-pong model. And now let's do a line-by-line comparison of the local version versus the framework version. And as you can see, there's not any difference as far as the flow of the code. So this actually matches line by line. Each line in the local version has a direct corollary in the framework version. So you actually write it exactly the same. The philosophy that was put into the design of the framework was basically that the programmer should never make direct access to the state. User interactions should be seen as regular functions, meaning kind of like the Python input function. This shouldn't kind of require you to return and then understand where you came from, but rather just be another line in the code. And the state must be fully persisted. This means that nothing is saved on the local machine. This is not like an async await type of situation where the machine waits for the client to kind of ping it back, because of course the client might hit a different machine if we have kind of multiple deployed servers. So nothing is local to the machine. Whatever state we need must be persistent in the database, just like it was in the server version. This is quite flexible. You can do anything that you can do in Python using framework code. For example, you can do conditionals, if statements. You can do loops, as we saw in the example. You can even do recursion, so call yourself. And you can run basically any piece of deterministic code. And we're going to look in the next. We're going to reach the next slides, and then we'll see what exactly I mean by deterministic code and when you kind of hit trouble when you try to write non-deterministic code. And yeah, basically, we're going to see examples. Okay, so this was the kind of motivation for why this framework is nice. I hope the example was clear. When the time that we have left, we're going to see, look a bit under the hood to see how it works. We're going to see some quirks of the system and caveats, and we're going to see some open issues and dilemmas that we still have in order to take this thing to the next level, and stuff that's still hard to do with the tooling that we have today. So let's start with how it works. I'll start with saying it's kind of similar to React hooks. If you know about React hooks, then you can kind of maybe see the similarity. If you don't, you can completely ignore this line. It doesn't matter. The basic idea is that each call to run persists the return value, meaning that after I call a function that's inside run, whatever it returns, I keep it in the database. Then when I actually reach this line called, which in the normal kind of Python code, when I reach the invocation of run, so I don't automatically run what's inside, but rather I check, do I already have a return value for this thing? If I do, then I just grab the return value without running anything. And if I don't, I actually enter it and run it and then persist the return value when I'm done. So this is kind of how we trick the code into starting in the middle rather than doing everything. We basically, it's sort of kind of a checkpoint mechanism. So we know how many run commands we already passed, and then we jump into the correct place in the code to continue the execution. So let's see some example, or sorry, just one example. So we have our first request. The state, subdialog states, which is in the database, is basically empty right now. And we reach this run get client response. This halts execution and waits for the next client request. And the next client request comes in and it has the number 5. So we populate this subdialog states list with the number 5. And then we wait for the next response, which is the number 2. So that's great. We go into the loop. The first run already has an answer. It's 5. Then we're in an infinite loop, so we go into it again. And then the next one has the answer 2. We save it in the database and wait for the next one, and so on and so forth. So we keep growing the subdialog states, and we know where we are according to the amount of return values that we have for run. Let's look at the framework API. We have this decorator called Dialog that we discussed. We have the 2 primitive dialogs that we export, which is get client response, which is like input, and send messages, which is like print. And finally, we have these 2 maybe poorly named functions, run dialog and run, where run dialog is really only used once in your code in the part that integrates the dialog code with the API code. Whereas run, you use it throughout your actual dialogues inside to call subdialogs. So subdialogues could either be these 2 primitive subdialogues or your own written subdialogues. So I'll discuss some of them. The decorator basically wraps a callable in a class. This is to achieve this thing, this conditional execution. So when I call this function, I don't want to execute anything. What the decorator does is it wraps the function that it decorates and returns this class object with a closure, and run kind of knows when to either run or not run the closure, depending if it already has the return value in the database. I'm going to show this code snippet from the library just because it's a bit crazy, but I thought it was cute. It's kind of a silly bit of code. Which defines the decorator, which grabs the wrapped function and makes a closure out of it that takes 0 parameters, and then puts this inside this object, this class called dialog with a capital D, where the interesting bit of it is it saves a dialog with the closure that it produced. And then the typing for this thing is also very interesting, as you can see. And finally, it doesn't return a function, but a class. And then run kind of takes this class and it knows whether it should run it or not, depending on the state. So I'm going to leave you with this for another second because I know it's a lot to take in. You obviously don't have to understand this to get the dialogue. I just thought it was a cool code snippet for PyCon. All right, good enough. Then we have get client response. This is also another interesting one, kind of from an implementation point of view. So basically, the way we achieve halting execution is by raising an exception. So at first, I kind of frowned upon this. I was taught that raising exceptions for non-exceptional situations is bad coding practice. So we started out using kind of iterators and yield, and then we used yield from to kind of call these things. It made the code kind of more boilerplatey. We couldn't just run, but we had to yield from run. And finally, I discovered that iterators themselves use exceptions to do exactly the same thing. So I thought it didn't even kind of achieve any kind of code Zen style because it actually uses the same thing. So I discovered about Python stop iteration, which is how when you iterate, for example, with a for loop over an iterator, then it catches the stop iterations, and then kind of that's how yield works, basically. So we wrote something very similar to this in the framework with a special exception, of course. So that's how get client response works. Send message is even simpler. All it does is accumulates messages in memory in kind of this message queue that it keeps between consecutive calls of get client response. And when it halts because it either reached the next get client response or the end of the dialogue, we can access these messages as we saw before with next.messages, and then we have access to basically all the output that we need to show the user. Let's talk about some quirks and caveats of using this framework. So I promised you a slide about non-deterministic code. So I kind of skimmed over this, but if I want to cheat a bit less, you can see that the line where I generate the random number isn't quite what we saw before with rand range. And the reason is that I couldn't use rand range directly. So the way that I achieved this was I wrote my own subdialog, which is the same syntax as the main dialog with this decorator. And here I return rand range, so the real Python function inside. And the reason this works is it only runs once. It only runs on the first ever client request to this dialog. Because for every consecutive call, I fetch the number that was already generated from the database. I only run this actual code on the first client request. This slide, I hope, also kind of shows how the thing works and more generally also for any piece of code, not just non-deterministic. So basically, it avoids running stuff if it was already run before and it has a return value. And other examples of non-deterministic code can be system clock, calls to time, or any kind of external API calls, database calls, anything that will not necessarily generate exactly the same output every time it's called. And this is kind of critical to isolate every single one of these occurrences inside its own subdialog, because if we don't persist the results, we risk kind of twisting the state of the whole thing. So we want to make sure that each time we go through the function, we go through exactly the same execution path. So this is a caveat, because obviously you can get this wrong. You didn't notice that you have some API call or something that's non-deterministic, and suddenly your whole backend goes haywire because you're not in sync. Basically, you're not going through the same path. And even kind of a more challenging problem is this updating the code. Basically, if I want to change the game logic, for example, before I ask the user to guess a number, I want to ask how they're doing and what their name is. So the simplest way to do this is you just can't do it. You cannot, once the user has already begun a dialogue, you're already committed to the specific code version, because the state that we save just wouldn't make sense with any changes to the code. So it's kind of safe to assume that any changes to the code will break any chat that's currently ongoing. So kind of the best we can do is restart. What basically happens is, let's say we guessed a few numbers, then we upload this new server version where we also want to ask the name before, and the user is happily guessing numbers, and then they get this message saying, it's over, what's your name, we're starting from scratch. Yeah, they already guessed 9 numbers, they were already going to win, and that might be a disappointing experience. So this is an illustration of what I mean by this. And also introducing a new feature here called version. As you noticed, my dialog decorator has empty parentheses, but you could also put an argument there called version. The numbers don't mean anything, it's just a string comparison. So, and this is kind of a way inside the framework to let the framework know that you updated your code and you're not allowed to continue simply with the previous state. So you can see the client is happy, he's playing the game with version 1. Then kind of in the second line, it's pinging the server, but the server was just updated with the new version, and suddenly it's version 1.1. And of course, because we're using framework code, then the client cannot continue. So they get a reset saying, we're sorry, you have to start over. And the client is kind of sad, but he says, fine, I'll start over. It's just a guessing game. But then something even more horrible can happen, which is, and this really depends on your particular flavor of DevOps. But for many systems, and we had this problem as well, during deployment, when we deploy a new version, we don't deploy everything at once. So we do have some moments in time where we have both the new and the old server version alive at the same time, which means that you can get the old version again if we're doing this deployment overlap window, and then the client is really mad because this can go on back and forth, and then this is bad for obvious reasons. So this is kind of a tricky problem. It has kind of more DevOps-y solutions, so not in code, which I'm not going to get into. But I will say that this is not really specifically a challenge of the framework. It's a challenge of any server upgrade that kind of needs to be friendly with the previous state of the application. What kind of makes it tricky in framework code is that this is made explicit. So when let's say that you make a change, but you know that you kind of understand how the previous database state was structured, so you can kind of guess what kind of changes you can do that will require a reset of the flow and what kind of changes will not reset the flow. And of course, you can make mistakes using this kind of reasoning. So here you don't have that luxury. You basically, you make changes explicit. It means you can't make mistakes, so you know the logic is far more sound. But on the other hand, upgrading is a much more violent act, at least if you use this mechanism directly, without kind of DevOps workaround to let the users finish whatever version they started. So final kind of overview of this version parameter, it must be updated manually. So it's not like the framework detects changes in your function code, but rather you have to state that you changed the version. If you fail to do so, then you have this little nuclear explosion cartoon, because you're basically loading state for a different code version, and you might interpret all the return values and everything in a completely non-coherent way. So that's a bad idea. And a version change, basically the best we can do is restart or have this little fallback dialog saying, we're sorry, but you have to restart because the code changed, and that's life. And there's a recovery mode to kind of try to understand more or less where we left off and continue from there. Another quirk is that dialog return values, as I said, are saved in the database. This implies that they have to be serializable. So, for example, you can't have dialog return something like an iterator or a lambda expression or a function because it can't be serialized. And so you cannot load this on the next time around. So you have to serialize it. And also, even for kind of stuff that's easier to serialize, for example, data classes, you still have to worry about serialization and deserialization. Because you need to, for example, know how to deserialize it into which data class and so forth. And at least the way the library is currently structured, serialization is kind of the user's problem. It's not part of the library. So we have this object called the game state, and you need to write your own serializer for whatever database you're using. So it could be SQL, NoSQL, JSON file, whatever. You need to know how to write and read this thing in order to use the framework. Open issues and kind of future directions that we're taking this. is the first is code versioning. As I said, the current system is a bit awkward. Really, the best thing to do is to have a DevOps fix for this. So kind of make sure that the user never has these version clashes, which kind of is making me think that maybe the best thing to do is to remove this feature altogether and just assume that it's the user's problem to never access state of code that was changed. As of course, without best practices and kind of clear advice on how to do this, then it's not much use. So that's why this is still an open issue, kind of the most robust way to go about this. The second is debugging and logging tools. Like any framework, when you kind of are currently debugging a line that says run something on it, and then you click step into, instead of stepping into the dialog, you're suddenly in this framework code. I'm sure you ran into this previously if you try to debug, I don't know, Flask or Django code in the backend. Any framework kind of sends you deep into its inner workings, and it's not as clear-cut as going line by line. But I think the experience could be improved in various ways. And also, there's a lot of potential here for powerful logging and monitoring tools, because having this state really allows you to do this time travel debugging and kind of understand exactly where the user, how the user interacted with the flow. Exactly, you can put timestamps on it and do all sorts of fancy things. And we didn't really explore these options yet. Finally, this isn't really an issue for us, so we didn't touch performance. But if you imagine doing something that's more high power, for example, using this as a part of some data pipeline, then you probably don't want to read and write so many times from the database in order to ensure the flow. This could be interesting for other use cases that are not a chatbot. And finally, maybe the most exotic and cool one is this idea of multiple client flows. So basically, currently we have this get client response primitive, which basically says I can only interact with a single user. So I wait for the user to send me the next request, and then it triggers the continuing the flow. It would be nicer to do something like maybe a poker game, where I have to wait for all users to maybe go in and take their bet, or I can say which user I'm waiting for, and make kind of a more rich synchronization, kind of a collection of synchronization primitives in order to allow more advanced flows rather than just this single actor model, which we have now implemented. So the applications that I just hinted at are, number one, chatbots. That's where it came from. So that's kind of what we had in mind. But it can really be used for any kind of long-lived workflow. It can be used for user journeys. So think like a shopping cart to payment to a feedback form or any of this stuff. So you can kind of keep the user going and know exactly where you are in the process. You can train machine learning models. So this could be kind of a more flexible alternative to declarative-based or UI-based or JSON-based pipelines. So here you can really write whatever you want. You can use any Python code, Turing complete, to define exactly the different stages and what you want to happen and how it's supposed to proceed. And the framework makes sure that the thing stays synchronized and you know exactly where you are. And also a similar use case, supply chains, which is kind of, we manufactured something, we want to know where it is in its journey towards its customer. So you can use this kind of flow lifecycle dialogue to, again, kind of each time the item reaches the next its next station in its journey, we ping this this ongoing dialogue, and we know where we are, and we can update it and do whatever actions are needed to keep the item moving along. That's it. Thank you very, very much for listening in. You're very welcome to stay after the talk and to go to the breakout room. The link to the GitHub page is in the description, and I'll be happy for any feedback or questions or collaborations or criticisms of any sort. So thank you very much. And finally, I have some thank yous to people, both code projects and people who helped kind of worked on this with me. So I won't list them here. The links to the project that I found relevant you can find in these slides, which will also be linked to in the description. So thank you again, and have a great conference.